Hi guys, recently in eBay I came across these tubes and I thought they'd come in very useful for a little issue that I've got regarding SMD components that come in strips like this. It's a common problem where you might be prototyping a board and you don't need to buy a whole reel of it, so it's just buy a small set, 10, 20, 50, something like that, and this is what comes. It's also get very disorganised because it's hard to keep a trace of them, so I thought these are quite small. I can fit a lot of these in one of these tubes, so that's what I'll be doing today. The main thing with these tubes is how to keep them organised and upright, because otherwise they'll just be all on top of each other and I'm none the better. So I do know that you can get ways, you can find ways to organise these that come pre-packed for you. One example of that would be in a catalogue like this, where you just get different types of resistors, 0805 these are, and you can just pick, but you don't always get that luxury. Now the problem with this is, again, I need an organiser. These larger test tubes that you might find in science classes usually have some holders, so it's nothing special that we're doing here. It's just my own means of doing it for this, because this is a very small diameter. I believe it is yeah, 10, but it does get a bit wider at the top. So we've got 10 at the bottom and roughly 13 the widest point at the top. So bearing that in mind when designing these, I believe the best way would be a little wafer like that, and then you just have your individual pockets for these within there. Now I'm not going to look to make this very thick or these to go through. I just like it to sit there quite tight, so it's a snug fit, and that's it. So now that we've got a rough idea of what we want here, let's just start identifying. So like I said before, we've got 10mm there and we have 13mm there, so we have to take the largest diameter at the top to be able to work this out in terms of spacing between them. So you're looking at something that, you know, you've got a diameter of 13, but then internally something that we have to think about as well. So internally looking at a diameter of 10. So difference here is 3, and obviously the circle will be 1.5 millimeters. So bearing that in mind, that's the key dimension that we need to bear in mind moving forward. So that would mean that you can draw a 10mm diameter circle, but the distance from one to the next needs to be 1.5 millimeters to be able to give you 3. So one unit will be have a 1.5 mil outer diameter, and the next one comes next to it, which will give you a grand total of 3 millimeters spacing. Now, given that it's a 3D printer, this level of accuracy is unrealistic, as we're not going to be able to get that. So we're going to have to go something like, instead of the 1.5, just go to 2 millimeters and proceed on like that. And then once we have this, we can then just array it into a nice pattern. I think one of the first things I'd like to do is just test to see how off my 3D printer is. Everybody's 3D printer is a bit different. I'd like to see how accurate mine is in terms of these dimensions. first thing I'll be doing is taking into Fusion 360 and modelling with the parameters that we've established and seeing if they will actually work and translate with the 3D printer's existing unique parameters, i.e. the tolerances that it has. As I said before, each 3D printer is different. So this is the first design that I'll be exploring. Then once I've finished modelling in Fusion 360, I'll quickly take into Cura and get a model ready to print. So I'll put on the screen some of the key printing settings that I've got for my printer. So this is the result that we got from the 3D printer in that first design as a test, just for cells. Now this is begins to be the problem of accuracy. It's not really tight enough to where we want it to be. So you can see here, very hard. I mean, it is, like I said, it is a 3D printer, plastic 3D printer. So, yeah, not the most accurate thing. So I think what I'll do is I'll recalculate these diameters and make them a bit tighter, so I can get this to hold it a bit tighter, and then we'll go from there. So one of the very first things I learned from my model was I don't really need to have a base. It just needs to be hollow. That's enough. So it saves on material and valuable printing time. So that's what I've done with this model. I got rid of that and made the diameters a bit tighter, and we'll see how that prints. So this is a revised part now, and this works from one side only very well. Holds it, doesn't fall off, very sturdy. So I'm quite happy with that, and this just reassures me to move forward with it, to print a bigger one. So yeah, let's do that. So after a long print, this is the result. Turned out okay. I printed in low quality, just a bit faster, and everything tends to fit in it quite well. Very tight and very yeah. So it's very tight, but it holds it very well. So yeah, let's see with a few more of these on in here. So you've got that one. So here's the final product. You can see it holds in everything very well. It's not perfect at all, but it does work for where I need it right now, which is just a bit of order. A few things that I'm probably revising in the future is that perhaps it is better that they are a bit flexible. You can move them a bit, because if you think about it, if you want to remove one of these, it becomes very difficult to remove. It can be done, you know, you can just pop it out the bottom. That's not a problem. So that works in that sense, but it would be nice just to be able to easily remove them. As well as that, I'd like to make this a bit more modular, so I could attach others next to it, but for now it works, and I hope you enjoyed the journey. Thanks for watching.